Hello Algebra 2 students, this is Ms. Prater and I'm going to work some review problems from Unit 6 review. I'll use this short video to send out to students who may have just general questions about Unit 6. I'll use this video to send out if you forgot to take the Unit 6 test, or maybe you didn't do very well on the Unit 6 test, or any quizzes in Unit 6. So this would cover a little bit of everything from Unit 6. Number 1 says that Kevin is observing the population of the fish he put into a pond. He built a pond and populated it with 500 fish. So 500 is going to be our initial amount. We're going to need that for our formula. It says that the population of the fish doubles every year. That's going to be important. That's going to have something to do with our rate. So I'm going to put a little R right there. Use X to represent the number of years and Y to represent the population of the fish. Which equation represents this scenario? So in mathematics, we have two separate formulas. One is growth, and that formula says Y equals A parentheses 1 plus R parentheses to the T or to the X. And then we have a decay formula. So growth is when in your problem something is increasing, something is growing. You would choose that formula. Decay is when you have something that is declining, depreciating, going downward. And that formula looks the same except for 1 plus R. It changes to 1 minus R, and then it has an exponent. So in this problem, it does tell us that our fish are doubling every year. So if there's 500 the first year, there'll be 1,000 the second year. Then it's going to double. So there'll be 3,000. There'll be 500 the first year. There'll be 1,000 the second year. Then 1,000 doubles. There'll be 2,000 the third year. Then 2,000 doubles. And then there'll be 4,000 the fourth year, and so on. So it's doubling. A is going to be your initial amount. So A stands for initial amount. R is going to be your rate as a decimal. This is important. This is something that we forget about a lot. So for example, if they tell you that your rate is 5%, you have to remember to move the decimal 2 places and use 0.05 in your formula. You can't use 5%, okay? So make sure you move your decimal 2 places to the left. And X is time. So in this problem, A is going to be the initial amount, which is 500. R, when something doubles, it increases by 100%. So that's just something you have to kind of understand there. So if it doubles, it increases by 100%. My decimal lies here. So if I move it twice, that means I'm going to use the number 1.00 as my decimal for my rate. And it says it says X is years. So it doesn't tell us how many years. So we're going to use this formula, and it's going to be Y, the number of fish, equal the beginning or initial amount of fish, 500, times, we're using the formula here, 1 plus our rate as a decimal. So that's going to be 1 plus 1.00 to the X. And then if we simplify what's in parentheses, we'll get Y equals 500, 2 to the X. And that's the last choice. All right, looking at number 2, which is the y-intercept of the exponential function. So the y-intercept is where the graph crosses the y-axis. So remember, the vertical axis, the one going up and down, is always your y-axis. And then the axis going left and right is always your x-axis. So we're looking for the point where it crosses the y-axis. Now I just took this equation and I typed it into Desmos, and took a snip of it. So I'm going to show you really quick how to put this one in Desmos, just in case you don't know. So you can just Google Desmos. I'll just Google it. I have it bookmarked, but you can Google Desmos, and then you're going to want the graphing calculator. And then you're going to type in this equation, f parentheses x equals negative 32 parentheses. Let's see how we're going to have to do this. I think we're going to have to open up the pad and do, no, we're going to have to go back. We're going to have to do 2 in parentheses and then this button. Right, and then that's raised to the x minus 3. And I'm just making a bunch of flub ups. We want to stay up here. Wonder if we have to put a parentheses. X minus 3 parentheses, arrow over. So 32, negative 32 to the 2 to the x minus 3 plus 3. Okay, so here's the graph. So that was a little bit hard to type in, so I'm glad we took the time to do that. So here's the graph. I just took a picture of it and snipped it into this problem so we could look at it. Now when the problem asks for x or y intercepts and they don't say write as an ordered pair, then you just want where the graph crosses the y-axis. So you don't want an ordered pair. You don't want to type in an ordered pair if the OLS doesn't say use an ordered pair. So you'll just type in the number where the graph crosses the y-axis. I know that's a little bit confusing. Number 3 says, what is the exponential form of this log equation? So we're going from the log equation to the exponent equation. So your subscript is always your base. So my base is going to be 0.8. The number on the opposite side of the equal sign is always your exponent or your power. And then the number that follows your subscript is always the answer. So 0.4096. And that would be this one. Even though the 0.4096 comes first, it's still the same thing. 0.84, 0.8 to the 4th on this side, and 0.4096 on this side. So you're not solving anything. You're going from log form to exponential form. In this problem, you're just going to straight up use your scientific calculator. I have Desmos scientific calculator. This is not graphing, but you'll have to go to function, and then you'll choose LN, and then go back to main and do 121, or if you have your own calculator, own scientific calculator, you can do it that way. So it's about 4.79579, and they're asking us to round to 4 places. So that's going to be to that 77957. So you look to the right of the 7, and the 9 is going to round that 7 up to an 8. So I have 4.7958. So just use a scientific calculator here. It could have said LOG of 121, and you would have used the LOG button instead of the LN button. Use scientific calculator. All right, let's look at number 5. This is another graph problem. It says which statements represent the relationship between y equals 4 to the x and y equals log base 4 of x. So I graphed both of these. So I typed both of these into Desmos. So just a quick reminder that to get this log base 4 of x, let me go back to Desmos. So if you're trying to do a log, you're going to have to go to functions, and then you're going to have to scroll all the way down. Maybe, maybe not. No, right here under the word calculus. And here's your log, and then you would put your subscript there and then type in. So again, functions, scroll down to calculus, and then you're going to use this log base A key to get that in your graphing calculator. So we're looking at the blue graph and we're looking at the green graph. So one of the things that I noticed when I just look at the graphs, I notice that these two lines are reflections of each other over the line y equals x. So there's this imaginary line that goes right through the origin, and it goes right through the middle of the first quadrant, and it also goes right through the middle of the third quadrant. So if I take the blue graph and I fold it over that line, I get the green graph. If I take the green graph and fold it over that line, I get the blue graph. So that proves that these graphs are inverses of each other. So we can check the first one. The graphs of the functions are symmetric to each other over the line y equals x. We can visually see that. And that also means that the functions are inverses of each other. The third one says y equals log base 4 of x is the log form of y to the fourth. Y equals 4 to the x. That's not true because that'd be 4 to the y equals x. So that's an untrue statement. And this one says the graphs are symmetric about the line y equals 0. The line y equals 0 is actually the y-axis. So these graphs are not symmetric about the y-axis. So it's going to be those first two. Number 6 is asking us to solve this log equation. Since there's just one log, then on most of the problems that just have one log, you're going to rewrite the problem in exponential form first, and then you're going to try to solve it that way. Anytime you can write the equation in exponential form, it's going to make the problem easier. So remember, your subscript is your base, so we'll write 5 as our base. On the other side of the equal sign is our exponent, so 5 is being raised to the y power, and that's going to be equal to the number that follows the subscript, 125. So you're going 5 to the first power. Is that equal to 125? Nope, that's 5. 5 to the second power, does that equal 125? Nope, 5 times 5 is 25. 5 to the third power, I'm just thinking this in my head. 5 times 5 times 5, that's 125. Yep, so y has to be 3. And again, it's just 3 in that open-ended question. You don't put anything else, but just 3. 7 is a little bit harder. This one doesn't have a log in it, but it's asking us to solve for x, and x is part of 5x, which is in the exponent spot. So the first thing I'm going to have to do is I'm going to have to try to get 21 to the 5x isolated. So right now on the left-hand side, 21 to the 5x is being multiplied by 5. So I have to first divide both sides by 5. That's going to give me 21 to the 5x is equal to, and then if you do 16 divided by 5 in your calculator, that's going to give you 3.2. And then this says 21 to what number is going to give me 3.2. There's no way that our human brains can figure out 21 to what number is going to give us 3.2. So this is when we must use logs to solve the problem. So that's why logs were developed, because there are some problems that we cannot solve in exponential form. So we'll have to apply log to both sides. So we're always going to use log unless we have a base of e. And if we have a base of e, then we would do ln on both sides. But this base is 21. It's not the variable e. So we're just going to take logs of both sides, and this is where we start to use our properties. We have 3 properties. Let me just remind you. 3 properties. One is called the product property. That says if you have log of m times n, then you can rewrite that as log of m plus log of n. We have the quotient property. If we have log of m divided by n, then we can rewrite that as log of m minus log of n. And then finally we have the power property, and that tells us if we have log of m to the n power, that we can rewrite that as n times log of m. So it's like the power comes out in front and gets multiplied times the log. So that's what's happening right here. we have a power. So we're going to bring it out in front, and we're going to do 5x times log of 21. Anytime we can take the variable that we're trying to solve for and move it out of the exponent spot, that's going to make our problem easier and more simplified and move us forward to solving. So we're solving for x. X is being multiplied by 5 and the log of 21. So we're going to divide both sides by 5 and log 21. Whatever we do to one side, we're going to do to the other. The 5's and the log of 21's will cancel. And they want the exact answer here. So they're telling you not to use your calculator. So this is going to give us log of 3.2 divided by 5 log of 21, which is going to be that last answer. Number 8 is asking us to solve for x, and if I take a look at this problem, the left-hand side is in base 2 and the right-hand side is in base 8. You could use logs to solve this problem, but if you can get both sides of your equation to be in the same base, then you don't have to use logs. And so it's always my suggestion is if you can get through the problem without using logs, it's going to be easier without logs. So the first thing that I realize is 2 is the smallest base that I can use on the left-hand side. So I'm going to leave the left-hand side just like it is, but then I'm going to replace 8 with 2 to the third power, because 2 times 2 times 2 is 8. So 8 is going to change into 2 to the third, and the reason that's helpful is now both sides are going to be in base 2. So what we have to remember is that 8, which we replace with 2 to the third, is being raised to another exponent, which is 3x minus 10. The left-hand side is as simplified as it's going to get. The right-hand side, we have a power raised to a power. So that rule is we multiply those powers together. That's going to leave me with 2 to the 9x minus 30. 3 times 3x is 9x. 3 times negative 10 is negative 30. Once your bases are the same, so base 2 on the left equals base 2 on the right, that means our exponents are the same. So that means you can drop the bases and then write an equation stating that if the bases are the same, then your exponents have to be the same. And then you'll just solve for x by subtracting 9x from both sides, and then solve for x by dividing both sides by negative 5, and then you'll end up with x equals positive 6. And then we have one more. On this problem, I did use Desmos. I typed my equation into Desmos. You're going to use just the LOG key here, so let's take a look at where that's located. Again, you would hit Functions, you would scroll down to Calculus, and then this is when you have a base other than 10. So this is just LOG. So on this problem, you would just choose the LOG button. I typed it in Desmos, y equals log, parentheses 3x plus 4, parentheses plus 2. I got this beautiful graph. It wants to know the x-intercept and the y-intercept. So remember, your horizontal axis, the one going left and right, is always your x-axis. So it crosses here. If you'll click on that button on Desmos, it'll pop up the ordered pair. It's not asking for an ordered pair, so you're just going to put the number where the graph crosses on the x-axis. So you'll put negative 1.33. And then the y-axis is always the vertical axis, the one that's going up and down. You'll click on Desmos on that point. If you can't tell exactly where it crosses, just click on it. The ordered pair will pop up for you, and then again, you just want the y value. So you could do 2.602, you could do 2.60. I think I just did 2.60 on this one. I probably didn't even use the 0. All right, hopefully this was helpful. If you have any questions about Unit 6, this should cover a little bit of everything from any quiz that's in Unit 6 or the Unit 6 test. Hopefully this was helpful.